here we go. What the problem says is that we're going to create an open box. And this open box is going to have a square base on it. And with the square base, we're going to have a height. So what we're going to do, and you may want to write this down, is we're going to have a volume of 48 cubic feet. Let's just say it's cubic feet. I don't know what the dimensions are. We're going to have a volume of 48 cubic feet. And it's going to be a square box with an open top. Now, the sides of the box are going to cost $4 per square foot. And the bottom of the box is going to be $6 per square foot. And we're trying to minimize the cost. Well, first off, we have to go into the volume. And we know that volume is equal to length times width times height. But since the bottom of the box is a square, we can say that the volume is going to be L squared times H. Okay. Now, here's L, here's L, here's H. And we need to get the cost. Volume will be 48. Now, we're essentially, the cost is going to be basically the surface area of the sides times $4 per square foot. And then the surface area of the bottom, which will be times $6 per square foot. So, surface area (6 times L squared) plus the sides. There are 4 sides, and each one of the sides will be 4 times LH. Is there a question with how we come up with that? Got 4 sides, the sides are LH, the bottom's L squared. Alright. Well, clean this up just a little bit. Surface area will be 6L squared plus 16. And instead of writing it as LH, I want this in terms of one variable. So I'm going to say that H is going to equal to 48 over L squared. I left off an L in there. I just substituted for the H and I left off the L there. But what's going to happen here is this L is going to cancel with one of those, and you're going to have 768 over L, which will also be 768 L to the negative first. Alright, haven't done any calculus up to this point. That's just how I will determine